Hello, class. Can you hear me?
Yep.
Yeah.
Okay.
Yes.
It's the second time I've had to reboot. WVU just cannot handle the volume, which is what the problem is. Typical of WVU, they want us to do something, but don't give us the tools. Well, as I started saying, question 5 and 6, one of the things that I had contemplated making part of one of the questions was how to maximize expression of the X gene and minimize the expression of the Z gene. And one mechanism for doing that is through codon usage. You could have the X gene use the most common codons so that there's plenty of charged tRNAs available, and the Z to use the very uncommon ones, so that the ribosome on the Z gene would be constantly pausing, waiting for a rare codon tRNA to come along, whereas the Z, or the X, sorry, would zip right along. This would allow you to build up a lot more X before the negative feedback or negative regulation of Z kicks in and shuts off the entire operon. Anyway, hopefully, I'm going to keep going. Even if we get dropped again, I will reboot and go through it. Okay, we're going to talk about something that's been sort of dear and near to my heart for the last 20 years when I got into the forensic science program, and that's forensic biology. Now, most of the work I've done has sort of been somewhat on the fringe. It's not STR related, but it is related to some of the bigger issues and in the field of forensic biology. As I say, this is can also be viewed as how to be a more informed viewer of CSI. I don't even know if it's still on TV. The steps in DNA analysis include confirmatory tests. Obviously, the first thing is at a crime scene, you need to identify what might turn out to be probative samples of some value in a courtroom setting. So once you've identified those, typically at the crime scene, what you're going to do is do a preliminary test to identify what kind of body fluid it is. It's not until you get it back to the crime lab that you do a confirmatory test. Then you have to isolate the sample. You cut out the, if it's on cloth, you simply cut it out. You isolate the DNA from that. A couple of different techniques for doing it. Typically with crime scene samples, it's often done with organics, the old-fashioned way. Compromised samples don't lend themselves as well to most kits. You have to determine how much human DNA is present. We'll talk about that in just a minute. You do the PCR setup, PCR amplification, and then the analysis of the data. And it's the analysis of the data that often takes the largest amount of time. Oops. Especially in the case of mixed samples, trying to understand what's going on. Okay, potential sources of DNA, just about anything you can think of that would have biological fluid. Obvious ones: blood, semen, feces, urine, hair,